60 tons. That's the weight of 9 adult elephants, lifted in a single grab by a machine that never throws a punch. This is the strongest scrapyard magnet on Earth, and the strange thing isn't the power. It's that you can't stop watching it. But before we get to the scrap heap, I need to show you what happens when a $2 million magnet loses power at the wrong moment, and the one piece of engineering that keeps a 40-ton metal fist from becoming a wrecking ball. This machine lives in a place most people never see, inside one of the largest scrapyards in North America. Every day, it swallows 30 train cars worth of twisted steel and spits them out as raw material for the next skyscraper, the next bridge, the next car you drive. But the real question isn't how much it can lift. It's how it lets go. This place moves more steel in a week than most cities move in a year. The yard stretches across 200 acres of twisted I-beams, crushed appliances, and the skeletons of old bridges, all waiting to be reborn. Every day, 66,000 tons of scrap metal enter facilities like this across the United States, enough to build 3 Eiffel Towers from the ground up every single morning. And at the center of it all, hanging from a crane that can be seen from 2 miles away, is a magnet the size of a small car. A circular slab of iron and copper that draws more current in 1 minute than a suburban house uses in a month. The principle is simple. Wrap a copper coil around an iron core, run a massive electrical current through it, and the core becomes a magnet strong enough to defy gravity. Release the current, and the field collapses. What it grabs, it drops. The problem is scale. A small electromagnet can lift a refrigerator. This one lifts 60 tons of jagged, unpredictable, interlocked chaos. Beams dangle at angles, cars tear loose, and the entire grab weighs twice as much as a fully loaded city bus. If something goes wrong, no one can run fast enough to escape the debris field. But here is where the engineering gets strange. The most dangerous moment is not the lift. It is the release. When the operator cuts power, the magnetic field does not vanish instantly. Residual magnetism can hold a 10-ton plate of steel for a crucial half-second, making the drop unpredictable. And solving that problem required a piece of technology so counterintuitive that it almost never made it past the design phase. Stay with me, because what comes next is what happens when a 40-ton metal fist hangs silently above a man, and the only thing standing between him and the ground is a whisper of current and a backup that no one has ever filmed. The man who knows this better than anyone still works the floor after 30 years. His name is Marcus. He's the one standing beneath the magnet when it descends, guiding the operator with hand signals older than the crane itself. I asked him what scares him most. He didn't say the weight. He didn't say the noise. He said the moment after the switch is thrown, when everything should drop, but sometimes, for a fraction of a second, nothing happens. That half-second is what keeps him awake. Because a 10-ton slab of I-beam still magnetized, still clinging to the plate, can swing like a wrecking ball in a hurricane. And if it releases late, the trajectory is completely unpredictable. Marcus has seen a chunk of steel the size of a refrigerator fly sideways and punch through a concrete barrier like it was drywall. No one was standing there that day. But the video from the security camera is still shown to every new hire. The problem is called remanence. Every ferrous material retains some magnetism after the external field is removed. With a 60-ton lift, that residual pull can hold thousands of pounds for up to a full second. To the operator in the cab, it looks like the magnet isn't obeying. You cut power, you expect a clean drop, and instead you get a delayed release. In a yard where precision matters down to inches, a 1-second delay can mean the difference between a neat pile and a crushed truck. Or a crushed person. But the real nightmare scenario is not the delay. It's what happens when the main power fails mid-lift. If a cable snaps, a generator seizes, or a circuit breaker trips, the magnet loses all current instantly. And without that current, there is no controlled drop. The magnetic field collapses chaotically, and the load releases wherever it's hanging. A 60-ton clawful of scrap, dangling 40 feet in the air, suddenly becomes 60 tons of gravity-driven shrapnel. That kind of accident has happened. In 1998, at a yard in Ohio, a generator failure dropped a full load onto a processing conveyor, destroying $1 million of equipment and sending a maintenance crew scrambling for their lives. No one died, but the industry took notice. That's when a small engineering firm in Minnesota proposed something that sounded insane. They wanted to keep the magnet partially powered even when the power was cut. A whisper of current. The system they designed is called a sustained field damper, and it works on a principle most electrical engineers are taught to avoid. Instead of switching off completely, the circuit redirects power through a secondary coil, creating a decaying sine wave that gently releases the load. The magnetic field doesn't collapse, it fades like a dimmer switch, giving the operator exactly 0.6 of a second to position the drop. And the backup? That's where it gets brilliant. A bank of supercapacitors, charged by the same generator that runs the crane, can power that damper for up to 3 seconds even if the main supply is severed. 3 seconds is an eternity when you're dealing with falling metal. It's enough time for the load to settle, for the field to decay gracefully, and for anyone below to take 2 steps back. But here's the part Marcus told me I could never film. The only time the capacitor bank was ever tested in a real emergency, the footage was seized by the insurance company and locked away. It showed a magnet hanging over a brand new processing plant, power lines cut by a swinging beam, and the damper kicking in so smoothly that the scrap didn't fall. It just kissed the ground. The operator thought he had witnessed a miracle. The engineers knew better. They had built a miracle into a box of capacitors, and they had hidden it in plain sight. Stay with me, because the next evolution of this technology is not about safety. It's about something even more valuable, and it makes the 60-ton magnet look like a toy. What makes the 60-ton magnet look like a toy is not a bigger magnet. It is a magnet that does not lift at all. 600 miles south of Marcus's yard, in a facility you cannot find on any map, a team of engineers has spent the last 5 years testing a magnetic system that never touches the scrap. The concept is called inductive ejection. Instead of grabbing metal and hoisting it, the magnet repels it. A rapid pulse of current through a specially wound coil generates a magnetic field so violently opposed to the target that the metal launches itself outward like a stone from a sling. The team calls it the flywheel pulse, and it works by turning the very remanence that Marcus fears into usable kinetic energy. In the test footage, I was eventually allowed to see a 300-pound steel plate shot 50 feet through the air and embedded itself into a berm of earth. Quietly. No explosion, no smoke. Just a hum, then a blur. The application is not about destroying things. It is about separation at scale. A standard scrapyard magnet can pull ferrous metals from a mixed pile. But what about the aluminum, the copper, the titanium, the alloys that are worth 10 times as much and cannot be grabbed? Right now, they are picked by hand or shredded and floated on a dense medium. The inductive ejection system flips the problem. By tuning the pulse to the conductivity of a specific metal, they can shove aluminum out of the stream without touching the steel. Copper cleans itself off the belt. Gold-plated circuit boards pop into a separate bin. The machine sorts trash into treasure at 30 tons an hour, and it works because the engineers realized something the whole industry had missed. Every metal carries a unique electromagnetic signature. A magnet doesn't just pull. It can also push if you ask the right question at the right frequency. The prototype was built inside an old warehouse in Texas, funded by a consortium of electronics recyclers who were tired of watching millions of dollars in rare metals get shipped to foreign smelters. The same supercapacitor bank that keeps Marcus's magnet from dropping its load was repurposed to store and release energy in milliseconds. The flywheel pulse generator occupies a space barely larger than a shipping container. It uses less power than the yard crane, but its potential is enough to have attracted a very specific kind of attention. In a sealed section of the test report I obtained under a Freedom of Information request, there is a single line referencing an alternative use case. The line reads, "Non-destructive separation of composite armor." Composite armor. The kind found on tanks. The kind that is layered with steel, ceramics, and depleted uranium. Someone, somewhere, is using this technology to pull apart military hardware. And that brings me to the part I promised at the beginning. The one piece of engineering that keeps a 40-ton metal fist from becoming a wrecking ball, the thing that is even bigger than the 60-ton magnet itself. It is not the damper. It is not the capacitor bank. It is the man in the cab holding a dead man's switch that, if released even an inch, sends a signal through a fiber optic cable to a relay that cuts the main breaker before a human heart can complete a single beat. That switch has never been filmed. The operators' union prohibits any camera inside the cab. But I found the patent for it. Filed in 2003 by a former crane operator who lost a friend to a falling load in 1994. He spent 9 years in his garage building a fail-safe that would react faster than fear. The patent diagram shows a simple grip switch with a spring-loaded trigger. Squeeze to lift, release to kill. It is the most important safety device in heavy industry, and its inventor died in 2017 without ever receiving $1 from the company that eventually licensed it. That story, the garage inventor who saved lives and got nothing, is a mirror of everything that happened in the scrapyard industry in the last century. The rise of the electromagnet, the consolidation of the recycling business, the suppression of safety innovations by insurance companies, the quiet, methodical work of a few men who made sure the rest of us could sleep at night while their machines tore the world apart and put it back together. Stay with me, because the final piece is not a magnet. It is a piece of paper. A document from 1942 that proves the U.S. government knew exactly how powerful these machines could become and chose to hide it. The document is a memo from the Office of Naval Intelligence, stamped April 19, 1942. Its subject line reads, "Application of high-Gauss electromagnetic fields to harbor defense." In the margins, someone has written by hand a single word, suppress. The memo details a classified experiment conducted at the Philadelphia Naval Shipyard earlier that year. Engineers had constructed a prototype electromagnet drawing power from a destroyer's generator. Its purpose was not to lift steel, but to magnetically fuse the firing mechanisms of German magnetic mines, rendering them inert. During a test, the magnet was accidentally powered to full output, while still aimed at a decommissioned freighter anchored nearby. According to the report, the ship's steel hull plates buckled inward over a 6-foot-wide section. No physical contact, just a magnetic field so intense it deformed thick naval-grade steel like a fist through tinfoil. The conclusion was immediate and absolute. A device capable of crushing a ship without touching it could not be allowed to exist in public hands, or in any hands other than the Navy's. The memo ordered all civilian research into high-Gauss magnetic systems to be classified, all laboratory results to be sealed, and all commercial applications to be limited to lifting magnet designs that never exceeded 2 kilogauss. That limit held for over 60 years. It is still referenced in some safety standards today. The world's strongest scrapyard magnet, even at 60 tons of lift, operates at a fraction of the power the Navy achieved in 1942 with vacuum tubes and rubber-coated copper. And that is the reason the inductive ejection system, the flywheel pulse, the supercapacitor dampers, all of it took so long to emerge. The research was there. It had just been hidden so well that no one remembered to look for it. The Texas team building the metal sorting pulse generator did not know about the Philadelphia test. They had reinvented a classified technology from the 1940s, and when they filed their patent, the government did not contest it because the original memo was still marked confidential and filed under the wrong heading in a forgotten archive. The only reason I can tell you this now is that in 2015, a retired Navy archivist digitized a box of old memos from the Philadelphia Yard, and one of them slipped through without a classification review. The memo that said suppress was now online, indexed, and strangely no one had read it until a scrapyard engineer in Ohio stumbled across it while researching capacitor discharge safety systems. He emailed me 3 pages of declassified circuit diagrams and a question. Did you know we've been limited to a fraction of what a magnet can really do? I asked Marcus about it. He leaned against the crane's steel leg and smiled. He said he'd always known there was more to the story. He said, a magnet that can pull 60 tons can push 60 tons. That's just physics. But physics belongs to whoever holds the switch. And the switch, the dead man grip that saves his life every day, was designed by a man who never saw that memo but understood the same physics in his bones. His garage prototype from 1994 used a relay timing circuit that, I now know, is an almost exact copy of a failsafe drawn in the bottom corner of a 1942 Navy blueprint. He could not have seen it. It was still classified. He built it from first principles, from fear and loss and love for the men he worked alongside. And when the patents were filed and the licenses were sold, his name was not on any of them. He died without a dollar, without recognition, except from the people whose lives he saved. There are 17 of them. 17 families who got to keep their fathers and mothers because a man in a garage understood that the most powerful force in a scrapyard is not the magnet. It's the person who decides when it turns off. If you walk into a recycling facility today and watch that 60-ton magnet descend, you are watching a machine built from secret physics, suppressed documents, and the quiet sacrifice of men who made safety out of struggle. You were never supposed to see the full picture. You were supposed to think it was just a magnet, but it was never just a magnet. It was a classified naval weapon, a garage inventor's love letter to the men he refused to let die, a patent filed in 2003 that echoed a blueprint drawn in 1942. It was the answer to a question the public never knew to ask. What happens when the most powerful force in a scrapyard is not the electricity, not the steel, but the quiet decision to protect the person standing underneath? The 60-ton grab, the whisper of current in the damper, the dead man's switch that reacts faster than fear, all of it exists because someone, somewhere refused to accept that accidents are inevitable. And the physics that could crush a ship without touching it still waits in a forgotten memo, still unexplored, still asking whether we are ready to handle a magnet that pushes instead of pulls. So I want to hear from you. What is the most powerful machine you have ever seen up close? Drop it in the comments. I read every single one. Hit subscribe. Not for me, but for the stories that get buried underneath 6 decades of classified ink. And if this content made sense to you, if you understand that the world is built on secrets like these, there is a special offer for you through the link in the first pinned comment below.